y are going to be like
two similar triangles. So what's with the similar triangles? What does that mean, similar? Similar means not equal. Similar means that I can show that they have all congruent angles. Similar triangles. Congruent, equal angles. And based on that, proportions with their sides. I cannot write proportions with their sides before I show congruent angles. If I cannot show that all angles are equal or congruent, then I cannot write proportions with their sides. But let's see if I only need to show two pairs. I don't need to show the third one because the sum of the angles in any triangle is what? What is the sum of the angles in any triangle equal to?
180.
180 degrees. Awesome. Brilliant. Thank you so much. Good. So, can I show congruent angles? Yes. Right triangle. Right triangle. Can I show another? Yes. A common angle. Do I have to show the third pair? No. But of course, these two have to be the same. So this angle in the small triangle is the same with the angle in the big triangle. These two are both 90 degrees. So these two have to be the same as well. Okay, but now I have to be careful how I write proportions. The order is extremely important. I'm going to start with the red angle. At the top, I will put all the sides of the small triangle. In the denominator, I will put all sides of the big triangle. Or vice versa, it doesn't matter. But I have to be consistent. These three have to come from the same triangle, and these three have to come from the same triangle. I would like to put the small triangle at the top and the big triangle, but you can say no. And I put it the opposite. It doesn't matter. So the red angle has an opposite side in the small triangle. How much is it equal to? The red angle has an opposite side in the small triangle. What is it equal to?
2.
The same red angle has an opposite side in the big triangle. What is it?
Y.
Perfect. I move on to the green angles. The opposite side of the small green of the green angle in the small triangle. What is its opposite?
X.
Move on to the same angle. What is its opposite? 12. Now I move on here. I know nothing about this. I'm just going to call it A. I move here. I know nothing about this. I'm going to call it B. A divided by B, but who cares? I don't know anything about it. This is my relationship. Cross multiply because it's a proportion. XY equals 24. X is a function of time. Y is a function of time. dx over dt is given to us. dy over dt is what we're asked to determine. at 4 meters away from the building. If he's 4 meters away from the building, what is the distance that he covered?
8 meters.
That's it. So when x equals 8 meters. Good. Can anyone differentiate for us?
X dy. X times dy dx.
Okay, so dx over dt, the first function prime, times y, perfect, plus x times dy over dt, times, of course, and this equals?
0.
Perfect. Again, that's why I needed this. I'm after dy over dt when x is 8. So I will move this term to the other side. X dy over dt equals negative y dx over dt. And I will divide by x. So dy over dt equals negative y over x dx over dt when x equals 8 meters. And now I plug in everything I need. So, negative. X is 8, dx over dt is 1.6, and I need to determine y. But how much is y if x is 8?
3.
Yes. So now I plug this in, or I can just simply say this is 0.2. 3 times 0.2, this will be negative 0.6. Measurement unit.
Whatever means per ones, meters over the time. Meter per second? Yeah, seconds.
Very good, awesome. Well done. Do we feel a little bit better about these problems? Okay.
I do.
Okay. Let's continue. Let's look at, I want to look at this. Let's read the problem. And this is my page 7. Okay. Okay, 29. So let's read the problem. Let's dissect each and every element. Careful with the trap, because they are trying to do that all the time. Gravel is being dumped from a conveyor belt at a rate of, I'm gonna copy the figure here. Okay, 30 cubic feet per minute. Stop, I refuse to continue. I have to identify what this is.
Volume dV dt.
Perfect. It's a rate of change. It has a measurement unit composed by 2 measurement units. It has to be a ratio. Excellent. Good. Okay. And its coarseness is such that it forms a pile in the shape of a cone. Yes, we have that. Whose base diameter and height are always equal. This is not the trap. Base diameter and height are always equal. Okay? Given. This is fixed, carved in stone. Or this. Whichever I need, I don't know. Okay, so this is fixed. It has to be used from the get-go. It doesn't follow when. Good. How fast is the height of the pile increasing? When, and that's the trap, when the pile is 10 feet high. How fast is the height of the pile increasing? So we are expecting a positive number when the pile is 10 feet high. So first I have the question, and then I have something 10 feet. Once I identify this, I'm in business. Let's look again. How fast?
CH to T.
Awesome, brilliant. What does this represent?
H.
Indeed, of course. Very good. Awesome. That's it. We are identified. We discovered everything. Now we are ready. What do I need? Which equation will I think of? It's okay if you don't know it, but which equation are we going to think of? Anyone? Just tell me which equation will you think of, and I will give the equation. The volume of a cone. Very good. So here's how you remember it easy. We know we already talked about the volume of a cylinder. And you can say, why are you connecting these? Here it is why. So the volume of a cylinder is pi r squared, area of the base, times the height. This one is the same, but divided by 3. So this is pi over 3, pi r squared, times the height. Very easy to remember. And now I'm going to put a dot. The volume of the cone is changing. The height is changing. Not the radius. The radius does not change. So the radius is h divided by 2. I need to replace this by h divided by 2, everything squared, because it's given in the problem. So then the volume of this cone is careful, I wrote pi twice. Please don't write it twice. Sorry, my apologies. Okay, so pi divided by 3 times h squared divided by 4 times h. R squared, h over 2, so I have h squared over 4, and times h. Okay, so then the volume is pi divided by 12, h cubed for our situation. Function of time, function of time. We are ready to differentiate. Can anyone tell us the left-hand side? Very good, awesome. The right-hand side. So 3 pi over 12 will be pi over 4 times.
The H to T.
Careful. We subtract 1 from the power.
H squared.
Awesome. Times dh over dt. Good. Perfect. I identify from the get-go what I'm asked to find. So then I will divide both sides. If you want, multiply by 4 and divide by pi h squared, and then plug it in, and it's done. So dh over dt, multiply by 4, 4 dv over dt. Remember, this is one unit. You cannot separate these. Okay? Divided by pi h squared. Because this represents one thing, one rate of change, I meant to say. Good. So we're told when age is 10. I plug it in. 4 dv over dt, 30. Let's make sure that everything is in feet. Yes, I think we're all everything that is given to us is in feet. Pi 10 squared. And I'll simplify by 2. You can say, why are we doing all this? Well, because I also want to see an exact number, and then we'll approximate it. Careful how you plug it in, remember. I prefer parentheses, but that's me. You know I'm in love with my parentheses. So 5 pi. Okay. So this is 0.382 measurement unit.
Per minute.
Very good. So the height is changing when the height is 10. At that instant, if you give me this a different height, then the rate of change will be different. At that point where age is 10, at that moment, the height is changing at 0.382 feet per minute. Is this okay?